Welcome to Corning's 5G in 5 minutes, or somewhere around 5 minutes. So, first of all, consider 5G is the first G that's not just a faster radio network. In the past, 2G to 3G to 4G/LTE were all just faster air interfaces. 5G is much more than that. We'll hit the 8 tech goals that combine to deliver, and there are 4 technology building blocks under the covers, and finally just touch on how LTE fits at the end of this. So 5G has 8 goals that were defined by the ITU to deliver the service, and there's some extremely important ones here. The latency, to drop it 10 times from a 10 millisecond target under LTE down to 1 millisecond. And that type of thing is important for robotic surgery and things where you have to almost have instantaneous feedback to let's say the person that's holding the scalpel on the far side. Um, the spectrum efficiency, well, when you look at the fact that you're going to have a connection density of a 10 times increase from 100,000 to a million devices per square kilometer, along with a area traffic increasing from 1 to 10 megabits per second per square meter, we're going to have this huge amount of devices. We're almost building 5G is the equivalent of a DAS stadium capacity, except it's going to be on the normal macro network. Macro meaning the outdoor network. And finally, you take that traffic capacity and the connection density, so 10 times the amount of devices and 10 times the amount of speed in the same area. Your connection on the back end of the cellular tower has to increase 100 times to support that new traffic density and the new speed goals that are available. So huge amount of fiber is going to be in this infrastructure, and when you get indoors, the fiber is going to go all the way to the edge where the radios are in order to support the capacity. And finally, depending on the network configuration, you could end up with potentially a peak data rate of 20 gigabits per second at the tower. So amazing things coming. So your 4 building blocks: 5G new radio, descendant of LTE. It's going to give you a 20x wider channel than LTE, from a 20 megahertz max today to 400 megs. And in order to exploit the ability to do 400 megahertz, you have to open up spectrum that has the available capacity to do that. So today, most cellular lives under the 6 gigahertz range. Now you're going to have above 24 gigahertz, and that's where the millimeter wave is going to be coming from. So when they talk millimeter wave, it means it's going to be this high capacity, high bandwidth spectrum. And under 6 gigahertz is the typical cellular you're seeing today. And you're seeing 5G deployed in all ranges. Next building block: massive MIMO. So if you're involved with wireless, you already know about MIMO on wireless Wi-Fi APs, and it's used quite commonly. And you're going to have massive antenna panels with many antennas to steer traffic and create beams to mobile devices. And outdoors, because of the spectrum that's used, the antennas will be many feet across. And indoors at millimeter wave, your antenna panels are 2 inches by 2 inches for many antennas. So very important technology to making 5G successful. Ultra reliable and low latency communications. This is a breakthrough technology to really allow the cellular network to handle super high performance traffic, and also highly critical traffic. And the best way to understand how low latency works with the scheduler and how packets get on the network, visualize the network as a freeway, and your thing that lets the packets onto the policeman. He when he sees a packet marked for low latency communications, it's the equivalent of a policeman seeing lights and sirens and telling the cars to pull over on the highway and allowing that packet to go by. So this is a whole new introduction into cellular, this technology in order to make high performance networks possible in the middle of a lot of the normal traffic that we run day to day. And the fourth building block technology is network slicing. And again, compared to enterprise networks, this is the equivalent of a VLAN, but this is an end-to-end construct. The radio network, the edge computer network, the transport network, like the MPLS infrastructure or the Metro Ethernet, and finally the core network and potentially out to the internet. You'll be able to configure a network slice that has a set of performance characteristics that are managed end to end, so that you can deliver a unique service and have each network slice run independent of each other, even though they're all physically riding on top of the same infrastructure. So the same kind of virtualization you see in computers with hypervisors, that's what we'll be running in the network for network slicing. And then finally, 5G and LTE, friends. LTE is going to be part of the 5G deployment. So 5G is deploying in what's called NSA mode. And if you look at that little Venn diagram down there, you can see that if LTE is out there right now, you'll have LTE service. If you have the mobile device being able to see the LTE service and the 5G new radio, you're going to have what's called 5G NSA, which is the configuration. But if the mobile device only sees 5G new radio, you won't have any service from a 5G perspective. So keep this in mind, and if you are sitting on budget money and waiting for 5G to come before you spend budget money on cellular network improvements for your infrastructure, if you buy LTE, it's not money wasted because you need LTE to implement 5G in the future. So if you defer your expenses and you don't satisfy people today with their LTE needs, surprisingly, when you go to do your 5G project in the future, one of the first things you're going to do is install an LTE network. So installing an LTE network today is not wasted effort, and it's not a lost investment because 5G deploys with LTE. So this has been Corning's 5G in 5 minutes. Hope it's been useful. And my name is Art King with Corning. Thank you.